Good afternoon all. This is Tesh Kumar, Assistant Professor of EC Department. Now let us see the another video lecture series on decimation in frequency FFT in discrete Fourier transform. This is the empathy part of fast Fourier transform. Slow DFT computations require high delay, power and inefficiency. Faster frequency analysis, we can reduce the computational delay and efficient hardware usage to optimize for limited resources. Real-time signal processing enable immediate signal analysis and a fast DFT processing for real-time efficient and low power. Next one, define a FFT algorithms is for efficient discrete Fourier transform calculations. DFT sequence for the sequence for representing the discrete Fourier transform. It is the efficiency achieved with the power of 2 power p, that is nothing but your efficiency. Complexity of FFT is nothing but order of n into log 2 of n. Next one is fast Fourier transform. You can convert the time domain into frequency domain, that is nothing but s of t into s of omega, that is nothing but fast Fourier transform. Next one, these are the methods of fast Fourier transform. There are two methods, DIT decimation in time and decimation in frequency. Next one, we can see the radix to DIT and DIF FFT. DIT means we can put it as a B. Capital A is equal to A plus B. Capital B is equal to A minus B into W n par R. W n par R represents the radix to FFT. And then DIF FFT means A is equal to A plus B. B is equal to A minus B into W n par R. Next one, this is the input and output sequence order. The input represents from your 0 to 7 in terms of binary form 000 to 111, and also in terms of bit reversed from 000 to 111 we can set as a bit reversed order 04261537. For in DIT and DIF FFT, number of complex multiplications required to compute is n-1 the whole square. Number of complex additions required is n into n-1. Next one, this is the 4-point decimation in frequency FFT. First, we can take it as your normal order. The output must be in your bit reversed order. 4-point means we can take it as first 4-point DFT. From the results of 4-point DFT, we can going to compute 2-point DFT. The output must be in your bit reversed order. Now we can see the problem ideate part of decimation in frequency. X of n is equal to 1, 2, 3, 4. Find x of k using 4-point DIF FFT algorithm. The input must be in a normal order 1, 2, 3, 4. While computing 4-point DFT, we can get the results as 4, 6, minus 2, minus 2. From the results of these 4-point DFT, we can going to compute 2-point DFT. We can get the results as 10 minus 2 plus 2j minus 2 minus 2j. We can separately write in your order in terms of 10 comma minus 2 plus 2j minus 2 comma minus 2 minus 2j. Next one, 8-point decimation in frequency FFT. This is the flow graph of DIF FFT. The input must be in your normal order. The output must be in your bit reversed order. First, we can going to compute 8-point DFT. From the results of 8-point DFT, we can going to compute 4-point DFT. From the results of 4-point DFT, we can going to compute 2-point DFT. The output must be in your bit reversed order. Now we can see the decimation in frequency stage 1. It is 8-point DFT sequence x of n is equal to 2, 1, 2, 1 using DIF FFT algorithm. See, only 4 sequence can be given, remaining sequence can be considered as 0. Therefore, the input must be in your normal order. We can write the we can compute the 8-point DFT of the sequence. We can get the results as 2, 1, 2, 1, 2, 0.707 minus j 0.707 minus 2j minus 0.707 minus j into 0.707. From the results of these 8-point DFT, we can going to compute 4-point DFT. We can get the results as 4200. 2 minus 2j minus j 1.414, 2 plus 2j and then plus minus j 1.414. We can get the results as such. From the results of these 4-point DFT, we can going to compute 2-point DFT. Finally, the results will be as 6200, 2 minus j 3.414, 2 minus j 0.586, 2 plus j 0.586, 2 plus j 3.414. The output must be in your bit reversed order. Next one, we can see the comparison of DIT and DIF FFT. Decimation in time means DIT FFT algorithms are based upon decomposition of the input sequence into smaller and smaller subsequences. In DIF FFT, it's based upon decomposition of output sequence into smaller and smaller subsequences. Splitting operation is done on time domain sequence. Splitting operation is done on frequency domain sequence in DIF FFT. In DIT FFT, the input must be in bit reversed order, the output must be in normal order. In DIF FFT, the input sequence must be in bit reversed normal order, the output must be in bit reversed order. Next one, we can see the mind map. For enhanced signal processing, we have need spectrum analysis. FFT analyze and direct signals effectively, and audio coding, it can audio and speech signals efficiently, and digital radio broadcasting, the FFT enables digital radio broadcasting modulation and noise reduction to reduce noise in mobile telephony signals. Next one, we can see the assessment. Define fast Fourier transform. Fast Fourier transform is to calculate the discrete Fourier transform with reduced number of calculations. In decimation in frequency, input must be in your normal order. Output must be generated at a bit reversed order. Define radix to DIF FFT means we can get it as a AB. Capital A is equal to A plus B. And capital B is equal to A minus B into Wn of R. List the applications of FFT. It is used in spectrum analysis, noise cancellation, and then biomedical applications, and then some type of radio applications. Determine DIF of x of n is equal to 1, 2, 3, 4. First, we can compute the 4-point DFT. From the results of 4-point DFT, we can going to compute 2-point DFT. Getting the results as x of k is equal to 10, minus 2 plus 2j, minus 2, minus 2, minus 2j. What is the difference between DIT and DIF FFT means? Splitting operation is done on time domain sequence in DIT. Splitting operation is done on frequency domain sequence in DIF FFT. In DIT, the input must be in bit reversed order, output must be in normal order. In DIF, the input must be in normal order, the output must be in bit reversed order. Thank you.